Welcome to the MS SQL Tips webcast, High Availability for SQL in VMware Without Raw Device Mapping, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips, and today's webcast host. Joining me today is Tony Tomarchio, who is the Director of Field Engineering for SIOS. He will discuss how to set up Windows clusters on VMware for SQL Server. He can tell you a little bit more about himself shortly. But before we get started, if you have questions, you can submit them anytime during the webcast by entering your question in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, watch videos, and post your SQL Server questions to be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with the links after today's webcast. So at this time, I'm going to turn things over to Tony, and he can begin.
Excellent. Thanks, Greg, and welcome everyone to today's webinar here. So again, my name is Tony Tomarchio. I'm with SIOS Technology. I'm part of the field engineering team here. And at SIOS, we focus on high availability and data replication solutions for Windows as well as for Linux. And what we're going to be talking about today is our ways to deploy traditional Windows Server failover clusters, specifically here to create a SQL failover cluster instance without the need for shared storage, as well as without the need to enable raw device mapping or RDMs. So we'll get into the details about how that all works and some of the challenges with clustering in virtual environments, different ways to do that, and then we'll talk about our DataKeeper solution and show you a live demonstration of how this all works. So what we're going to be talking about here is the concept of Sandless clustering. Really what we also mean here is a shared nothing clustering architecture where cluster nodes aren't all using the same shared storage. They're not connected to the same shared set of disks here. And this is an excellent way to achieve high availability, native high availability for SQL, but this will also work for really any workload. This could be file servers, this could be custom applications, you name it. So before we jump in, I just want to do a quick poll. So Greg's going to pull up a poll here. Basically, how are you providing high availability for SQL Server in your VMware environment today, if at all? So Greg, can you fire that up?
All right, we'll let this go for a little while and get some people voting here.
Okay, excellent.
So we got about half the people voted so far. Let me let this go just a bit longer, and then we'll share the results.
Perfect.
All right, we'll take another 10 seconds. If you haven't voted, please vote. All right, I'm going to close this down. I want to share the results. All right, so we have 40% said VMware HA, 28% said always-on availability groups, 23% shared storage clusters with raw device mapping, also 23% said no high availability, and 17% said other.
Okay, excellent. So it looks like we've got folks doing this kind of in all different types of configurations here. So that's excellent. So what we're going to be focusing on here today is a method for basically setting up a traditional fully clustered instance of SQL here, but without the shared disk requirement. So what I have up on the screen here is, when I say the word cluster, this is generally what people envision. Two or more servers. These could be physical servers. It could be virtual machines. They could be instances up in the cloud. Just two systems that are connected to some shared disk, and you fail over locally between them. One issue with a shared disk cluster is that technically the storage is a potential single point of failure. If that particular piece of shared storage goes down, it can take out your entire cluster. So shared storage represents a potential single point of failure. Additionally, when you look at this specifically in VMware environments, generally the way that you will present shared storage to your virtual machines is by using what VMware calls raw device mapping, or we'll refer to them as RDMs. Now the challenge with that is when you enable RDMs, oftentimes you lose some of the hypervisor level features that you know and love, things like Vmotion, DRS, and so on. So, in order to achieve high availability and obtain a fully clustered instance of SQL, oftentimes you have to sacrifice some of the virtualization capabilities that you're used to and that you depend upon. So what SIOS brings to the plate here is what we call a Sandless cluster or a shared nothing cluster. And this is where replication comes into play. And replication technology will replicate the independent storage allocated, in this case, to each virtual machine. So using SIOS solutions here, what you can do is you can very easily take two virtual machines, and you would assign them each their own independent set of VMDKs or virtual disks. Now, our software will replicate that at the block level, either synchronously or asynchronously, such that both of these VMs will have a replica of the volume that live on these VMDKs. So, for example, you have these two SQL servers. Let's just say they have an equally sized D volume on each one. Our software is going to essentially perform a software RAID 1 mirror across the network. So whatever data gets written to one gets replicated in real time over to the other. And to take this a step further, we've integrated this replication technology with Windows Server failover cluster, so you can present independent storage to the cluster and make it look as if it was shared storage. So this basically, lets you achieve the best of both worlds. You get to set up a native SQL failover cluster instance, yet you don't lose some of the key capabilities that the VMware platform provides, like Vmotion, DRS, sometimes snapshotting and things like that. So with this type of a configuration, you've got these virtual machines with independent storage. We're doing real-time replication. And just as you would expect, if you have a failure of one of your cluster nodes, whether the VM dies or SQL inside the virtual machine dies or something to that effect, failover will take place. Windows Server failover cluster will fail the SQL instance over to the remaining cluster node, and it will tell DataKeeper to start replicating data in the opposite direction. So where originally data was being replicated from the left server to the right server, well, now it'll be going in the opposite direction here. So full integration with Windows clustering. So the way that you manage your cluster, the way that you install SQL into the cluster, all of that is as you know it today, right? It doesn't change your day-to-day life. We're just really doing replication behind the scenes transparently to the cluster and abstracting the storage to make local storage look like a piece of shared storage to the cluster here. So when you deploy this, you've got a lot of different options. Sure, you could take just two virtual machines. They could each have their own VMDKs, and you could go with a two-node configuration. But you've got additional flexibility. Maybe you want more than two nodes. Maybe you want those nodes to all be in the same data center. Maybe you want them to be in different data centers, so you can have a multi-site cluster, which is also a great disaster recovery solution. So the diagram we have here up on the screen, this is what I call a 2x1 cluster. So this is a nice use case for a scenario where perhaps you already have an existing cluster. You already have two VMs. You might be using raw device mapping here today to share that one to the two VMs. Now maybe you want to have a third virtual machine at a secondary data center, so we can replicate that shared storage from the active node at data center 1 over to the third cluster node at the secondary data center. So this is an excellent solution for both local HA as well as remote failover or disaster recovery. So GeoCluster is really best of both worlds, HA and DR, in a single configuration here. So that might be where you have an existing cluster and you want to add a node at a different site. Again, these are all virtual machines here. Or you could even mix and match if you really wanted to. Now, to take that a step further, that third virtual machine, maybe you don't have a secondary data center, so perhaps that might be an instance up in the cloud. It could be Amazon or Azure or something to that effect. So again, mix and match server and storage type here. Now, if you want to eliminate the shared storage completely, and you want to do a geo cluster here, you could look at a configuration like this, where this looks like the original slide where I had 2 nodes, simple 2-node cluster, but here I've added a 3rd node. Again, this 3rd node could be at the same data center, could be at a different data center, could be a virtual system up in the cloud. So what we see here is that we're actually doing multi-target replication. So right now the SQL Server is running on the node on the left. So server 1, let's say, it's replicating both the server 2 and a server 3 in parallel. And should I have a failover and the 2nd node comes online, well, that new server becomes the source of data replication, and it would replicate back to server 1 and then over to server 3. So with this type of solution, you don't have to worry about mirror management, making sure that your data is replicating in the right direction. That happens automatically, and it's all controlled through failover clustering. So failover cluster just fails over the SQL instance to the node that it needs to, and it tells DataKeeper where the data should be replicated going forward. So you don't have to manage your HA and your replication separately. It's all, again, the way that the cluster looks and acts and feels it's as if you had a traditional shared storage cluster, but we're eliminating that shared disk requirement here. So oftentimes I get asked, well, aren't there other ways to do this? And sure, most commonly we'll get asked, well, how does this compare to always-on availability groups? So always-on availability groups is a database-level replication technology that was introduced with SQL Server 2012 and newer. But one thing to keep in mind is that availability groups is a feature that's only available with SQL Server Enterprise Edition. So if you're a Standard Edition customer, maybe you don't want to make the jump to Enterprise Edition just for HA because of the increased cost. If you don't need any of the features that Enterprise Edition provides, and really all you need is high availability, well, using DataKeeper from SIOS is an excellent solution to allow you to do that, because Microsoft allows you to form a 2-node failover cluster using SQL Standard Edition. Now, if you need 3 or more nodes, you need to make the jump to Enterprise, or if you need any of those other type of features. But this can really reduce your SQL licensing costs, and at the same time ensure that you've got a cost-effective way to achieve high availability without losing some of the key features that your virtual environment provides. So that's one. There are also differences in the areas of compatibility, in protection, and then also in performance. So with availability groups, it's not compatible with distributed transactions. So if you or your application relies on MSDTC, then availability groups isn't going to work for you. But with DataKeeper, because we integrate with failover clustering and you are actually setting up a SQL FCI or a failover cluster instance, you can also cluster MSDTC if you need to. So, additionally, with availability groups, it only protects the certain user-defined databases that you've specified. So your system databases are not replicated and are not protected. You're essentially, with availability groups, managing 2 separate standalone instances of SQL. So things like your SQL logons, your SQL agent jobs. If you make a change to one, you need to make a change to the other. So there's additional administrative overhead to keep your 2 servers synchronized from that perspective here. Now with a SQL failover cluster instance using DataKeeper, again, because the entire instance is protected and replicated, all of that just fails over. You're managing one clustered instance of SQL, regardless of which node in the cluster it's running on. You don't have that added administrative overhead. With DataKeeper, you can also, as I mentioned before, you can easily deploy a cluster that has more than 2 nodes here, and you can have automatic failover to as many nodes as you need. Of course, the cluster will set up the failover order, but this could be a 3-node, 4-node, it could be even more, depending on your recovery time and your recovery point objectives here. So you could set up an n-node cluster and have automatic failover to any node in that given cluster, just as if you would in a traditional shared storage SQL failover cluster instance here. Additionally, because DataKeeper is really, it's a disk level replication technology, so we're replicating Windows volumes. because we replicate Windows volumes, we can replicate more than just your SQL data. If you have important mission-critical data that perhaps lives outside of the database, it could be PDF files or flat files or just some custom file or that lives inside the Windows volume that you care about protecting, well, DataKeeper can replicate that as well. You simply tell the solution which drive letters you do or don't want to replicate, and whatever data lives inside that volume, whether it's SQL databases or logs or other types of files, that will all get replicated in real time. So this is real-time, continuous block-level replication here. I have a slide coming up that talks about replication efficiency. There are also some pretty significant differences in regards to replication performance and how replication with availability groups versus DataKeeper can have an impact on the performance of your SQL Server. So performance is a concern. You definitely want to take a look at this type of a configuration here with DataKeeper integrated with failover clustering. So what I brought up here is a comparison between a native, non-mirrored, non-replicated SQL Server, comparing that to always-on availability group replication, as well as DataKeeper replication. And in all scenarios here, when replication is involved, we're talking about synchronous mirroring here. So again, maximum data protection, so there's no data loss here with synchronous mirroring. And the bar at the bottom where it says no mirror, what we did here is we took a server and it had pretty high-end storage in the back end, and we ran a simple workload to really just insert as many rows into a database as possible. And we were seeing in this example over 1 million rows per second being inserted. We then took a pair of SQL servers, configured availability groups, and turned on synchronous replication. That had a pretty severe performance penalty, 60-70% overhead, so it really dragged things down here. So we turned that off, and we did the same test, but this time using DataKeeper's block-level replication, which is much more efficient, and we were seeing somewhere in the 10 to 15% range. So much better performance. The replication isn't going to negate the performance boost you have from deploying that faster storage in your infrastructure here. So I bring this up because that's probably the #1 question that I get asked as well. What other ways can you achieve SQL high availability without having to leverage shared disks or raw device mapping? And availability groups is generally what comes up the most. So we talk about the addition differences, the compatibility, the performance, and the protection level differences here. So with that, I'm going to switch gears here, and we're going to take you through a live demonstration and show you how this works, how you can set up, in this example, it's a 2-node Windows Server failover cluster with a clustered instance of SQL, and how that works without actually presenting shared disks to your cluster nodes here. So let me stop presenting the slides here, and we'll bring up this environment here. So I have a failover cluster. So here's my cluster. It's called SIOS wsfc.demo.local. And it's a 2-node cluster. My servers are SIOS 1 and SIOS 2. And I actually have a couple of different clustered roles here. I've got a highly available instance of SQL Server. And I also, just to show you that this can work with any clusterable service or application, I also have a highly available file share here as well. For the most part, this is going to look and feel and act like your run-of-the-mill cluster, but there are a couple of key differences here. The first being the witness. In a traditional shared storage cluster configuration, what you would use is if you have an even number of nodes, you would generally use a quorum disk. So you would present a small disk to both of the cluster nodes, and that would be your quorum disk. In a configuration like this, where you have the 2 virtual machines, they each have their own unique set of VMDKs, there is no shared storage here, so you can't use a quorum disk. That's why Microsoft gives you the option to configure a file share witness, which is just a simple file share that the cluster nodes communicate with. In this case, this would be my 3rd node. So I've got SIOS 1, SIOS 2, and then the file share witness. So I have an odd number of quorum votes. So that's one difference from a traditional shared storage cluster where you're leveraging RDMs to pass and map the storage directly back to the virtual machine. Now, the second difference is if you look at the cluster disks. So in your traditional shared storage-based cluster where you've mapped the shared LUNs directly up to the virtual cluster nodes here, you would have what Microsoft calls a physical disk resources, cluster disk XYZ, the shared LUNs here. Now, when DataKeeper is involved, what we've done is we've created our own disk resource type. Microsoft calls this a third-party storage class resource. So this is our DataKeeper volume resource. So as an example, I've got this DataKeeper volume S, and it's currently assigned to the SQL Server cluster role. This is where all my SQL databases and logs live here. So this looks like a single piece of storage. But in reality, I have an equally sized S volume on my two virtual machines. So SIOS 1 has an equally sized has an S volume. SIOS 2 has an equally sized S volume as well. DataKeeper is mirroring that volume and presenting that to the cluster as a single piece of cluster storage here. And in just a moment, I'll show you how we get the replicated disk resource into the failover cluster. If we go back to the cluster roles and I take a look at my highly available instance of SQL here, this all should look the same if you've ever set up a shared storage cluster. I've got the network name, I've got the IP, here I've got my SQL Server and my agent resources. I'm clustering MSDTC as well. And here's the differences in the storage section of this cluster role. Again, we're using this replicated disk resource instead of a shared disk resource here. So the DataKeeper Volume S is part of this cluster role. And when you actually install SQL into the cluster, you go through that wizard halfway through the SQL installer. It asks you which cluster disk you want to use. That's where you would just simply check the box next to the DataKeeper resource. So again, the way that you install SQL, the way that you fail over SQL, the way that you manage SQL in this type of a configuration, where you're using local VMDKs on each VM and not some type of shared storage, that all remains the same. So going back to the storage section of the cluster, I've got a handful of DataKeeper volume resources here in my cluster. Now, the way that I got them into Failover Cluster Manager was through this DataKeeper user interface here. So this is a simple MMC snap-in, and you'll see in just a moment, but in order to create a mirror and have that presented to the cluster as shared storage, it's a simple three-step wizard. So before I create a new mirror, let's take a look at an existing one. So here I've got this job called SQL Data and Logs. And if I click on that, I can see information about what is being replicated and where. So I'm replicating my S volume, as we saw in the cluster. The source is SIOS 1. The target is SIOS 2. So that matches with the cluster because the cluster currently has that role running on SIOS 1. So this matches up here. And I can see the IP endpoints. So if you have multiple virtual networks, it's always a best practice to separate your replication traffic from your quote-unquote normal traffic, your user or your application traffic. I can see that my mirror is in a mirroring state. If it wasn't, if it was paused or resyncing, I can see how much data is outstanding between source and target. And this happens to be a synchronous mirror here. If we go down and take a look at this overview screen, specifically the server overview report, I can see the various drive letters that I have on my systems, which ones are being mirrored versus which ones aren't, what the role is, who's the source, who's the target, and so on. What we're going to do right now is I'm going to create a new mirror, and we're going to replicate this R volume that I have on the system. So to do so, I simply click the Create Job button, and I go through a simple wizard. First, we're going to give it a name. I'll just call this R drive, and click Create Job. Now we go through this three-step wizard. So step 1, I pick my source. Step 2, my target. And step 3, my mirror options. So my source is going to be SIOS 1. Now I have multiple network interfaces on the system here. So I've got this 10-10-10 network, or my quote-unquote private network. And this is where I send all my replication traffic over. Finally, I'm going to select the drive letter that I want to replicate. So I've selected R. And now I'll click Next. On step 2, I select my target options. It's actually pre-populated all of this for me. It knows that the other machine is called SIOS 2. It selected the network interface on the same network and it's selected the same drive letter. So nothing needs to be changed on this screen. If you had more than 2 nodes, you might select node 3 or 4 or what have you from the screen if you want to set up mirrors to different nodes here. So I'll click Next once again. And finally, this is where I specify my mirror options. Both of these virtual machines are in the same data center, so they're connected by high-speed, low-latency network connection. So I'm going to put this into synchronous mode. But you do have the option to also perform asynchronous replication. So generally speaking, if you have a high-speed, low-latency network connection, synchronous replication is recommended. With synchronous replication, it's essentially a double commit. So anytime data gets written to your primary node, the write is not considered complete until it's safely made it to both your primary and your secondary cluster nodes, so both source and target. But you factor in the round-trip latency into your write performance here. With asynchronous, there's no performance impact, but there is potential for some in-flight data to be lost if you have a hard failure of your system. Now, you always do have crash-consistent data, but people generally, of course, don't want to have any data loss, so synchronous replication is preferred if your network will allow it. And that's it. I'm going to click Done here. So this is going to create the new mirror, which is going to replicate the contents of my R volume from SIOS 1 over to SIOS 2. And I was just presented with a message here asking if I want to register this new mirrored volume as a cluster disk with Windows Server failover cluster. So I'm going to say yes here. So I have this new R drive mirror. I can see that SIOS 1 is the source. It's in a mirroring state. SIOS 2 is a target. If I click on this particular job, I can see similar information: source, target, volume, IP endpoints, and so on. Now, if I switch back to the failover cluster manager interface, you can see that this brand new DataKeeper Volume R resource was added into the available storage pool. So it's sitting here inside the cluster. It looks and feels and acts just like a shared disk would. But the benefit with this is now I have these 2 virtual machines. They're just using independently attached VMDKs, so I can Vmotion these systems, anywhere I like. I don't have those types of restrictions as if I, was leveraging raw device mapping to pass a shared LUN on your SAN, let's say, up directly so that the VMs could access them directly here. So I've got this DataKeeper Volume R in the available storage pool. Now, the last thing I'm going to show you here in the demo, and then we'll open this up for Q&A, is how failover works. So just like you would expect, if one of your cluster nodes fails or if SQL fails and it can't be restarted, the cluster is going to initiate a failover. So what I'm going to do now is I'm going to initiate this myself, and we're going to move the highly available SQL instance from, currently it's on SIOS 1. We're going to move this over to SIOS 2. So this all should look familiar. It's stopping everything on SIOS 1 and starting things back up on the other cluster node. As part of this process, it's also failing over the DataKeeper resource automatically. So I don't have to go in and tell the cluster that, well, data needs to be replicated in the opposite direction. That happens automatically. So it onlined the DataKeeper volume resource now on SIOS 2. So replication is going in the opposite direction. My SQL Server is back online, and everything is good here. If I go back and look at the DataKeeper interface, I can look at this particular job, and I see that the roles have been reversed. So the source is now SIOS 2. The target is SIOS 1. So the direction of replication has been switched here. So again, this is all happening seamlessly, beneath the covers of the cluster, if you will, here. So that's it. This is actually very simple to set up. Again, anybody who's ever set up a Windows cluster or a SQL cluster, you already know 95% or more of what it takes to accomplish this. The DataKeeper Cluster Edition product from SIOS is really providing this value add, and it's enhancing the native capabilities of Windows Server failover cluster to now allow you to set up a cluster without shared disk. This is especially useful in VMware environments because now you have an easy method to create highly available SQL instances without leveraging raw device mapping and therefore losing some of the key features that VMware provides that you know and depend upon. So With that, I'm going to bring up just one last slide here, and then we'll open it up for questions. So just briefly, just a little bit of background on who we are here at SIOS. So SIOS has actually been around for well over a decade. We are a Microsoft Gold certified partner, and DataKeeper is logo certified for Windows Server 2008 R2 and everything newer. So this is a fully supported configuration. Basically, just ensure that your cluster passes cluster validation when you form it, and you're good to go. So this is a fully supported solution here. We've been around, as I mentioned, for well over a decade, protecting all kinds of applications and data worldwide for all different types of customers here. So SQL is definitely the number one use case that we cover on the Windows platform, but also file servers, custom applications, SAP, lots of different applications and databases that can be protected with this type of a configuration here. So I guess with that, if you want more information, you can visit our website at us.sios.com. We also are going to be having a follow-up session led by my colleague Dave Birmingham, who is a cluster MVP, and he'll be going through Clustering 101, top 5 ways to protect SQL Server in a VMware environment. That's on January 28th. If you want some information, visit our website at us.sios.com, or you can also email us at info@us.sios.com. So with that, I just want to thank everybody for their time and interest here today. And Greg, why don't we go ahead and open it up to Q&A here.
Okay, sounds good. And actually, Tony, if you can take a look at the chat, there's a new link that David passed over. If you want to just put that up on the screen, and that just gives people some access to additional resources. And while we do that, why don't we go through some of these questions? And if anybody else has questions, feel free to submit them right now using the question component of the GoToWebinar tools. So the first question goes back to one of your slides about multi-site cluster. And the question was, what is the guaranteed downtime for failover? Can it be zero downtime? Is that possible? And also, that is kind of, how do you achieve this without losing any data?
Sure, great question. So I'll take that in some different chunks. So I'll take that last part first. How do you do this without losing any data? So the best way to ensure that you have zero data loss is you would leverage synchronous replication. That's the best way. Now, of course, if you're doing this across a WAN and there's some latency, as a user, you need to weigh a couple of different. There's some trade-offs here, right? So with synchronous versus asynchronous replication, there's always the classic trade-off of performance versus data loss. And you have to decide what's more important here. Because with synchronous replication, there will be zero data loss because any data that gets written, it's safely made it to the other side as well. So zero data loss. But you do have to factor in round-trip latency, and that will affect your write performance here. Now, on the other hand, if, performance is more important than you're okay with maybe losing a little bit of data, well, that's where you would go with asynchronous. So to answer the question, to ensure zero data loss, synchronous replication is really, the appropriate way to go. Now, in regards to zero downtime, well, the way that failover clustering works is when one node fails, the other one comes online. So there is that little blip in the middle where if you have a hard failure of a server, that first server will go down, and then the failover time is basically as fast as it takes the other node to start up SQL Server and things like that in the other node. So there always is going to be a little blip, if you will, but the remaining server will come up with the full set of data as the primary node, especially if you're using synchronous replication here. So you've got crash-consistent data on the remote side. The same behavior as if you were doing a single-site cluster with shared storage, the traditional way of doing this. When one node fails, the other node then comes online with, a copy of the data. In the shared storage case, it would be the same copy. We're dealing with a replicated copy. So I hope that sufficiently answers the question.
Okay, great. The next question is related to failover, and just wondering, how does the SIOS replication handle failover? So if there's an issue with the VM host or the guest or something that causes failover, can you just talk through that real quickly, how the whole failover process works?
Definitely. So Our software actually doesn't do or control the failover. That's actually all controlled through Windows Server failover cluster. So the cluster is what is monitoring the resources and the servers, and the cluster nodes are heart beating and all of that good stuff. DataKeeper is simply the disk replication technology software that is ensuring that your data is synchronized between the different cluster nodes. So if and when you have a failure, whether that is the failure of a resource inside the cluster, like maybe the SQL process dies, or there's an issue with the virtual NIC, or maybe the virtual machine gets killed, or maybe even more severe, maybe the VMware host dies completely. So the cluster is monitoring all of that, and in a failure situation that it can't recover from, that's where it would initiate failover to another node in the cluster. When that failover is initiated, as we saw in the demo, it tells the DataKeeper resource to come online on this new cluster node. And in doing so, it is telling DataKeeper to switch the direction of replication, so that the node that's coming online becomes the new source of the mirror, and the original node would become a new target. So DataKeeper isn't actually performing or controlling failover. That's all done through the cluster, and it is really, the cluster tells DataKeeper which way the data should be replicated based on which node in the cluster is active.
Okay. The next question is related to the use of DataKeeper. So again, this presentation is all about VMware, and the question is, does this work for other things besides virtual machines?
Oh, it most certainly does. So DataKeeper is just software that you install on your Windows cluster nodes. To that effect, this works on physical servers. It works in VMware. Any type of a virtual machine, could be VMware, could be Hyper-V. Pick your hypervisor. Or this can also be done up in the cloud. We have a number of customers who deploy clusters up in Amazon EC2 or up in Azure. So yeah, this is server and storage agnostic. Today we were primarily focusing on one particular pain point that customers bring to us, very commonly, which is I've got this VMware infrastructure. I'm deploying, or I want to deploy mission critical SQL Server, and I need full HA for this. I don't want to leverage raw device mapping because I don't want to lose some of the key VMware functionality. So that's why they come and talk to us about this type of a solution. Now, of course, VMware has some HA functionality built in, as we mentioned in the poll earlier. Some of you are using VMware HA, right? And that's a type of a solution where it's really going to protect you against hardware failure. So if the VMware host dies, it reboots the VM on another node. But essentially, what's running inside the VM is a black box. So by deploying Windows Server failover clustering with DataKeeper inside the VM, now you have application level awareness here. So really the best of both worlds. Certainly, you can still use VMware HA. Most people use VMware HA as well, and then they'll deploy guest level clusters inside the VM.
Right, one of the slides, Tony, you showed the comparison of mirroring always-on availability groups, DataKeeper always-on availability groups and no mirror. And just wondering if you can talk a little bit more about the performance overhead for using DataKeeper. Does it really impact the SQL Server at all, or the applications running against it?
Sure. So let me bring that slide back up here. Just one moment here. Yeah. So any synchronous replication technology is going to have some impact, and that's just because of the nature of how any type of synchronous replication technology works. With synchronous mirroring, it's a double commit. So when a write comes down on node 1, that write isn't considered complete until the data has also made it to node 2 and the acknowledgement has come back. So double commit. So because of that, round-trip latency between the servers factors in, because the write isn't considered complete until the data can be sent over to the other node, written, and the acknowledgement come back that it's been safely written. So in this diagram here, what we did is we ran the same SQL workload. It was really just a simple workload of inserting rows into a database as fast as possible, and we actually did this with a host that had very fast SSD storage inside. That's why some of these numbers you see are pretty large. And with the no mirror at the bottom, that was just a standalone VM running SQL Server, no cluster involved or anything like that, just inserting rows into a database. We saw, 1 million rows per second or just over. Now, the row above it, the SQL Server always-on availability group synchronous replication row, the gray bar there, that's where we then took a pair of VMs, set up always-on availability groups with synchronous mirroring. This we had 10 gigabit interconnects between everything, and that had a pretty significant performance penalty. That same workload was only able to insert just over 200,000 rows per second. Then we turn off availability groups, and instead of availability groups, we leverage data keepers block-level volume replication, and because it's a much more efficient method of transferring data, it had a much lower impact on performance. So yes, there still was some performance impact. Again, this is just writes are impacted, reads are not, and data keeper was showing 10 to 15% overhead in that case.
Right, the next question is related to the back end from one node to the other, and the question is, do both nodes need to look the exact same or be set up the same way? So does it have to have the same kind of size disk drives, the same RAID levels, et cetera, or can they be different?
Sure. So they can be different. I mean, your different cluster nodes could have different numbers of CPUs or virtual CPUs, different amounts of RAM, things like that. From a disk perspective, when you're dealing with a cluster, the drive letters need to match, and the sizes should be identical. More specifically, the target volume needs to be the same size or greater than the source. If the target volume was smaller, it wouldn't have enough blocks to replicate the entire volume over on the source side. So the target needs to be the same size or greater. If it is greater, you're just going to end up with some wasted space, so the recommendation is make them identical. In a virtual environment like VMware, that's really easy to do. You just say add a VMDK, and you type in the same number on both VMs, you get an equally sized disk there. But you certainly can mix and match. I mean, we even have situations where maybe one cluster node is a physical server and the second cluster node is a virtual machine. So you can do that. But basically, drive letters and sizes should match. Now, in regards to performance, again, ideally, you want the speeds of these disks to match as well. Just clustering in general, you want your cluster nodes to be identical, or if not, as close as they can, just so that when you do fail over between them, you get the same performance, same configuration, all of that good stuff. Now, if you're in a situation where your primary server has much faster storage than your secondary cluster node, you could notice different behavior. Well, with a synchronous mirror, if the target disk is a lot slower than the source, well, that basically throttles down your write performance on the source, because you can only write as fast as it can be written to both sides. So your slower disk becomes the limiting factor there. Now, if you were doing asynchronous replication, and let's say your source disk was twice as fast as your target, and you're really hitting it hard, well, your mirror might never catch up, because your source volume is writing, let's say twice as fast as your target. Your mirror would never catch up, so it would never be caught up. So neither of those situations is ideal. So best practice, same drive letter, same size, and ideally, same performance.
Okay, the next question is about data replication, and this is kind of a two-part question. So the first part is, does DataKeeper replicate the system databases? And then secondly, can you just talk a little bit about the differences between using this versus always-on availability groups? I know you already mentioned the need for the Enterprise Edition, but kind of reiterate what clustering gets you versus over the always-on.
Sure, certainly. So the first part of the question, do the system databases get replicated? Yes, absolutely, because in a cluster configuration, the cluster or the system databases will live on a cluster disk. So in our case, that means they end up living on a replicated DataKeeper volume. So yes, the entire instance is protected. So master, MSDB, all of those are going to get replicated. So when it's brought up on the other cluster node, it's all there. Same concept to if you were doing this the traditional way with shared storage. Same thing. The system database would live on that shared LUN so that the two nodes can see the exact same set of data. Same principle applies with DataKeeper. We're just working with a replicated disk here. So that's one. Now to elaborate a little bit more on the availability group differences, we mentioned that again availability groups is only an enterprise. It's an enterprise edition only feature. Availability groups does not replicate your system databases. Availability groups is not compatible with distributed transactions. And then also, availability groups only replicate user-defined databases. So if there's data that maybe lives on the file system outside the database, that's not going to get replicated as well. Those are some of the, and also then we've talked quite a bit about the performance differences between the two technologies. So those are the main differences. Again, the cost, because standard versus enterprise edition of SQL, compatibility with distributed transactions, and then the protection level, where a fully clustered instance of SQL with DataKeeper is going to protect and fail over the entire SQL instance, versus availability groups is just going to replicate and fail over certain user-defined databases. So those are some of the key takeaways as far as how they're different.
Okay, the next question is related to applications. So in order to take advantage of clustering or clustering with DataKeeper, are there changes needed? Do changes need to be done for applications to work with clustering, or is it kind of just seamless?
It's just seamless. So the fact that DataKeeper is involved doesn't affect how your cluster works or how your applications interact with the cluster. When you set up a cluster, you've got a network name and an IP. So just like you would point your application to in a non-cluster environment, you point your app to the name or the IP of your SQL Server. In a cluster environment, you just point it to the name or the IP of the cluster instance of SQL, so that when it moves between the different cluster nodes, it's got the same name, it's got the same IP. It's really just the application doesn't really know that the database is now running on a different cluster node. It might have seen a little blip during failover, but then SQL's back online, and it just connects back into the same name and IP. So, no, you shouldn't have to do anything special to your application with the fact that there's a SQL cluster behind the scenes.
Okay, Tony, when you did the demo, when you did the failover, I think there's a little confusion. This may just be for people that haven't done much with clustering. So they just said they noticed that the S drive failed over. But can you kind of just talk through what happens in a cluster failover as far as services go?
Sure, certainly. So when failover happens, basically the resources are moved from one cluster node to another. So what I did earlier, and I can do this again here, is I failed over SQL from SIOS 1 to SIOS 2. So what it did, and this was what I call a switch over more so, because this was user initiated. I told the cluster I would like to move SQL from one node to the other. So when it does that, it actually stops everything on one node and starts it back up on the other. So let me move it back. So I'm going to move the SQL Server from node 2 back to node 1. And when it does that, it takes everything offline on node 2, and then it's going to start everything back up on the other node in the cluster. As part of that, it's also doing that same thing for the DataKeeper resource. So it's bringing the DataKeeper resource online now on SIOS 1, which under the covers tells DataKeeper to switch the direction of data replication. So where data used to be replicating from SIOS 2 to SIOS 1, now that I failed this back over to SIOS 1, the DataKeeper is replicating the S volume from SIOS 1 back to SIOS 2.
Okay, the next question is related to the distributed transaction coordinator, and the question is, why is it supported with DataKeeper and clustering, but always on availability groups it does not work?
That's a good question. I mean, DTC can be clustered, it's clustered with Windows Server failover clustering. It's independent of the back-end storage type that you use. I probably have to look up and see exactly why DTC isn't supported with availability groups. My guess would be because it has to do with, changing host names or something to that effect. But, I don't want to give an incorrect answer here, so I'll probably have to take that offline here.
Okay,
the next quick Google search would come up with it, though.
Yep. Okay. The next question is related to replication, and the question is the entire disk replicated, or can you pick certain files that are part of the disk, or how does that whole thing work as far as replication?
Good question. It's at the volume level. So you would select, one or more drive letters, and whatever drive letter you pick, whatever files that live in that drive letter get replicated. So you can't pick just certain files or folders. It operates at the volume level. Now that said, if you have a large disk, and you want to replicate the entire disk, you could partition it up into, let's say, maybe 3 volumes, D, E, and F. and perhaps you only replicate D, but not E or F. So you have the flexibility to select which drive letters you do replicate versus not, but it doesn't get more granular than that. It's at the drive letter level.
Okay, the next question is related to the mirror copy, and just wondering, this is kind of a two-part question as well, is can that mirror copy be used for like read-only operations, number one, and then secondly, how does this actually work? Are the databases in a detached mode behind the scenes and SQL Server is attaching them on the secondary node, or can you just kind of explain that a little bit?
Sure, certainly. So the first part of the question is about leveraging the standby node. So while a mirror is in normal operation, for example, the S drive on SIOS 1 is open for reads and writes as you would expect, but the S drive on the standby node is locked, so you actually cannot access the data on the standby side. Now that said, DataKeeper does provide a feature we call target snapshots, which can allow you to access a point-in-time copy of that data. So it's a bit different than, with availability groups, they've got the readable secondary, which is a continuously updated and up-to-date, read-only copy. With DataKeeper, you get access to the volume, it's point in time. So common use cases for that would be, maybe nightly reporting or nightly backups. You want to offload that to the standby node. So you might, let's say at the end of your workday, you take a snapshot, you run your backup on the standby node, or you run your nightly reporting, and then the next morning you drop the snapshot and then repeat the next day. So that's that. Now, the second part of the question about attaching and detaching databases, you don't need to worry about that because the cluster handles all of that automatically. So remember, with a clustered instance of SQL, you're not managing two separate SQL servers. This is one clustered instance of SQL. So you don't go to both sides and create databases and make changes on that side. You just connect into, in this case, you would connect into the name of the clustered instance. In this case, it's called DKFCI. So you always connect into the same name or IP, and it just happens to route you to the active cluster node. So upon failover, the cluster automatically handles moving the virtual IP, switching over the disk resource, starting and stopping SQL. You don't have to worry about attaching and detaching databases when that happens. That's the beauty of doing this with a cluster. Now, if you just wanted to replicate data and you didn't want to set up a cluster, you could also use DataKeeper on standalone servers. But yes, in that case, if you had a failure, you'd have to manually start SQL and then, yes, attach databases and things like that. But that's really the beauty of setting up a cluster. Is the whole point of the cluster is to automate and do all that stuff for you.
Okay, the next question I'm just going to read as it was typed in. Hopefully this all makes sense. So it's, can you use DataKeeper to just mirror VMs without automatic failover? For example, if the primary fails, you have to manually switch your application to the mirrored IP address. And it says, I guess what I'm asking is using DataKeeper with the Cluster Manager.
Yeah, okay, so it sounds like, like using DataKeeper without a cluster, right? So DataKeeper comes in two editions. There's Cluster Edition, which is really what we've been talking about here today. And then there's DataKeeper Standard Edition. DataKeeper Standard Edition would be used on servers that are not part of a failover cluster. Again, this could be physical servers, could be VMs, could be cloud. And in that case, what DataKeeper is doing is it's just replicating data from one server to another. So let's say you have two virtual machines, they're not part of a failover cluster, and you have important data that you care about or SQL databases, and they live in the D drive. So we'll replicate D drive to the D drive on the other VM, but because there's no cluster, if the first VM fails, well, you're going to have to do a number of manual steps in order to bring things online in the other one. You're going to have to start up SQL. You're going to have to attach the databases. You're going to have to tell your users or your applications now to point to a different name or an IP. So you have to perform all the steps yourself that the cluster would have automated for you. But yes, if all you're looking for is just data replication and you don't want to set up a cluster or you don't need auto failover, perhaps you've got a pretty high recovery time objective where you're okay with an hour or more of downtime or however long it takes you to do things on your own, you could leverage Standard Edition of this product as well.
Okay, the next question is, does DataKeeper work with Zen Server?
So DataKeeper, we are just software that runs inside the Windows operating system. So honestly, it doesn't matter what hypervisor you use under the covers. So this, could be a VM, Windows VM on VMware, or it could be a Windows VM on Hyper-V, or it could be Zen, or KVM, or it could be a VM up in, the Amazon or the Azure cloud. So it's all we really care about is the version of the, you have to be running a supported version of the Windows operating system, which is 2008 R2 and everything newer. Other than that, we don't care if this is physical, virtual cloud, or if it's virtual, we don't care what hypervisor it's on. So it'll work on any of them.
All right, the next question, Tony, is related to the replication. And the question is, if there's an issue where replication breaks, the other server's not available or something like that, does SQL Server continue to work, or does everything just stop at that point? Can you?
Okay, sure. Excellent question. No, SQL does not stop. So there could be a couple of different scenarios where replication is interrupted. First could be perhaps the network between the two systems is interrupted. Maybe a switch went down, or a cable went bad, or who knows what might have happened. But that's one scenario where replication might be interrupted. Another situation might be, let's say patching. You're doing rolling upgrades, and you're applying a whole bunch of Windows updates to your standby cluster node, and then at some point you have to reboot it. The server's down for a little bit during that reboot process. Well, your SQL Server on the primary doesn't stop functioning, right? What happens is DataKeeper automatically detects that the mirror has been interrupted. It wasn't able to send the data from source to target. When that happens, the mirror automatically goes into a paused state. And in that situation, DataKeeper leverages a bitmap file, and this is how we track which blocks have been changed versus which ones aren't. So we know exactly block for block which blocks are in sync versus out of sync. So when the network or the server comes back up and the mirror is resumed, which happens automatically, DataKeeper performs a partial resynchronization. So it just copies back over the delta. So yeah, in that situation where your standby node is down or things like that, you wouldn't have failover, but the node that's up isn't going to be affected. The SQL is still up. It's writing data to the local machine. Those data changes just aren't being replicated until the mirror resumes and does that resync.
Okay, the next question is related to replication as well, and just wondering, is the replication continuously happening, or does it only happen when there's a failover?
Great question. No, this is real-time continuous replication. So it's happening all the time. When failover comes into play, that's when the direction of replication will switch. So the source and target roles will swap. But replication is always happening. Think of it like a software RAID 1 mirror, but instead of the two disks living inside the same machine, now they're connected to different machines over the network. So yeah, anytime data is written, well, we've implemented DataKeeper as a filter driver, so it sits right beneath NTFS and essentially intercepts writes as they come down. And when a write comes down, one copy of that block goes to the source server, and the second copy of that block goes to the target, all in real time. So continuous data protection.
Okay, well, let's take one more question, and we'll wrap things up. So this last question is, if somebody wanted to use DataKeeper, that is, for non-SQL purposes, they were just wondering, does it allow bidirectional replication? Is that possible to do that?
Yeah. So for a given drive letter, replication only goes in one direction. So your D drive replicates from node 1 to node 2, let's say. You don't have continuous read-write access to both sides. We don't do bidirectional replication for a single drive letter. Now that said, this would be applicable to, let's say, maybe a multi-instance SQL cluster where different instances are running in different nodes. You can have different drive letters replicating in different directions. So you might have your D volume replicating one way and your E volume replicating the other way. So that's, a way if you had, let's say, a multi-instance SQL cluster, you could have one SQL instance on node A and a second SQL instance on node B, where they're each effectively a backup or failover for each other, right? So I'll refer to that as like active-active at the cluster level, but it's active-passive at the resource level. So given cluster resource is only ever running on one node in your cluster at any given time. I hope that helps.
Okay, great. Well, we're actually out of time, so we're going to wrap things up. So thanks once again, Tony, for all that great information, and also want to thank SIOS Technology for sponsoring today's event. So please visit SIOS at us.sios.com to learn about all of their SQL Server HA solutions. And also, I sent that link out to everybody in the chat window, so follow that link for the follow-up webinar. The webcast was recorded, and you'll receive a follow-up email with the links to view the archive. Hopefully have that up either late today or sometime tomorrow. Also, please visit mssqltips.com to access all of our free SQL Server resources. I want to thank everybody for attending today, and when you exit the webcast, please take some time to fill out the survey. The feedback helps both with today's webcast as well as future events. Thanks again, and hope you all have a great day.